In this series of lessons, we are going to take a look at airflow and duct, and we're going to get an understanding of how airflow affects heating, cooling, and ventilation in a building. Now, airflow, we have to remember, is a lot like electricity, a lot like the flow of water. It will always go to the path of least resistance. So if you remember that as we go through these lessons, it's just going to make it easier. Now, these PowerPoints are adapted from a book by Leo A. Meyer, part of Lama Books. It's actually a pretty nice set of books, and it's adapted from a book called Airflow in Ducts. So again, if you want to have the hard version of this along with a lot of extra information, I do suggest you go to lamabooks.com and take a look at the Airflow in Ducts book. And so let's get started with lesson one. Okay, what our purpose in this lesson is, we want to have an understanding of the basic components of an HVAC system. We want to understand why air flows in ducts, and we want to understand what inches of WG means, because that serves the basis of where we're going next. So when we take a look at a duct system, okay, we have several components of a duct system that are pretty important to understand the location of. Okay, what we do is we start off, we have the supply air. Now, when we're looking at a duct system, we look at it from the point of the system. Okay, so from the point of the fan is where we want to take a look at things. So the supply air is coming out of the supply air fan and is going to the building or to the conditioned space. The return air is coming back from the conditioned space and coming back into the fan through the filter. On some commercial systems, we also bring in outside air. Okay, for ventilation purposes, we have to do air exchange in a building. We sometimes have to exhaust air as well. Okay, because if we're bringing in outside air, we need to take the same amount of air and push it out of the building. We don't want to overpressurize a space. We'll talk more about that. We have an exhaust air damper, and we have an outside air damper. So when you see EA on a plan, that's exhaust air. When you see OA, that's outside air. SA is supply air, and RA is return air. We also sometimes have a return air damper. Okay, we'll talk more about what that's for, but basically it allows us to mix the air in different spaces. So when you look at the area right before the filter, okay, to the right of the outside air damper and below the return air damper, that's mixed air. It's a combination of outside air and return air. Depending on temperature and humidity, as well as a variety of other building needs, we may bring in more outside air and less return air from the building, or we might bring in less outside air and more return air. Okay, and that's the purpose of those dampers. It allows us to do better with the mixed air. Okay, allows us to control what makes up the mixed air. So one of the systems we might take a look at is a chilled water system. Now, that you see most often in commercial systems, but this could be a residential air handler, okay, with a regular refrigeration coil in it. So where the big circle is up at the top, that could be your compressor, okay? In this case, that whole yellow outline is part of the chilled air system or the chilled water system, okay? Now, here, there's a chilled water coil. So from our last PowerPoint, we just had the filter. But this one, we're adding a coil. Okay, this is a cooling coil. Okay, we don't have to worry much about, is it chilled water? Is it refrigerant? In this case, for our conversation, it's a cooling coil. Okay, but some additional parts you may want to know about, chilled water return. Again, we're looking at it from the standpoint of the system. So the chilled water return is the water going back to the chiller. Chilled water supply is the water coming to the coil. So again, supply and return, we're always looking at from the system that generates it. we have a chiller, and then we have our coil. Okay, a coil, all it is a bunch of copper tubes and fins. I really, for the standpoint of airflow, do not need to know what's within that coil. It could be refrigerant, could be water, could be glycol, could be just about anything else. It is a coil that air blows across, and in this case, it gets the air coming out of the coil should be cooler than the air coming in the coil. Hot water system, basically the same thing. You have a system that is sending hot water to a coil. Now, I really don't care what is controlling that system, okay, or what is generating the hot water. In this case, we have two boilers. So we have a hot water coil, we have boilers, we have a pump, we have our hot water supply, and we have a hot water return. Again, that coil in there could be refrigerant, could be water. In this case, it's water, could be anything else, could also be electric heat strips. For the purpose of airflow, I really don't care. Okay, it is something that is heating the air that's coming across it. So, when we take a look at a basic duct system, we have airflow that comes out of the blower. Okay, when you see the symbol that's on the left-hand side, that's a blower or a fan. So we have return air coming into the blower, and we have airflow being pushed out of the blower. Coming out of the blower, as with any type of pump, on the output side, it is high pressure. Then we spread the air out, okay, of the duct at the end of the ductwork. Once it leaves the ductwork, most often through a register or a grill, there's low pressure on the outside. Okay, we have some basic tools we use to measure airflow, okay, because airflow is able to be measured. Okay, the one on the left is an electronic manometer. The one on the right is a Utube water gauge. Now, pressure in ductwork is always measured in inches of water gauge. You'll also see this sometimes just as inches of water column. So the WG stands for water gauge. Okay, one water gauge is 0.04 psi. Okay, so 0.04 pounds per square inch is 1 inch of water gauge or 1 inch of water column. Now, let's figure out what water gauge or water column is. And I understand I'm using the two alternatively, water gauge and water column. It is really the same thing. Okay, so let's take a close-up view of this Utube manometer. Okay, we have a flexible hose that connects to the ductwork or wherever we want to be taking the reading from. Okay, we have a glass tube. We have a level line that goes across both sides of the U. Okay, so right now this Utube manometer is zeroed out and it is at room air. Okay, where we don't have any pressure on it. It's level. And that's very important. You need to be level. Okay, now we connect it into ductwork. And you'll see that the left-hand side of that, where C is, dropped. And where D is, it increased. So we now have a pressure difference between the room air and the area within the ductwork we're measuring, because that's really what we're measuring. We're measuring a difference in pressure. Okay, so we have our duct, we have airflow, we have air pressure that's going into the sampling tube. We have a 0.04 inch drop on the left side, and we have a 0.08 inch rise, or we have a 0.04 inch rise on the right side. You add those together, we have a 0.08 inch pressure difference. So the pressure reading is the difference between C and D. Again, a negative and a positive of 0.4, okay? So we're pushing the level down and we're pulling it up. And by the way, there is an error on the PowerPoint here. Okay, if we're pushing down 0.4, the other side goes up 0.4. That is a 0.8, not a 0.08. Okay, now how much of that is in PSI? Remember, 1-inch water column is 0.04 PSI. So that's a really small number at this point. So that takes a look at our basics of ductwork air pressures, okay, the basic components and what we're going to be talking about. So on our next PowerPoint, we're going to continue on with the discussion based on that.